So in this video, we will see disinfection or sterilization and breakpoint chlorination. So the module is 1, water technology. In that, the topic is disinfection or sterilization, which is the 5th step in the water treatment, which we have seen in the last video. Water treatment for getting potable water. So we have seen in the last class water treatment from raw water to potable water. In that, disinfection and sterilization is the last 5th step, followed by breakpoint chlorination, which is also in this sterilization or disinfection step. Okay, so we will see this, what we have seen, just quick recap to continue the 5th step. Okay, this is the steps we have seen in the last class, steps involved in the last video, steps involved in the treatment of water. Like you take raw water, then first step is screening, second step is sedimentation we have seen, third step is coagulation, then fourth step is filtration. Comes next, 5th step is disinfection. Okay, so that is what we are going to see, the 5th step directly. We have seen this 4. We have seen this 4 already. We have seen. Today we will concentrate on this part. Okay, disinfection is the 5th step to get potable water. So we know that potable water means safe for drinking and cooking. Purposes. Okay. Okay. Okay, what is so this is the 5th step in the treatment of raw water to potable water. The process of destroying or killing the disease producing bacteria and microorganisms, etc. from the water and making it safe for drinking is called disinfection. Okay. The chemicals used for killing bacteria are called disinfectants. Okay. So water can be sterilized or disinfected. Water can be sterilized, or we can do disinfection by boiling, chlorination. In chlorination by adding bleaching powder, amine, chloramine and direct chlorination, and also by ozone. Okay. So we have seen this type of not only for drinking water, any water, for example, swimming pools, which is used by a lot of public. Okay. So the water has to be periodically cleaned. That which is done by, we have seen chlorine. So we get chlorine smell. Okay. So chlorine is used to swimming pools are disinfected or sterilized. Swimming pool water is sterilized by chlorine, either directly or by adding bleaching powder, anything. So swimming pool is one example we have all seen. There's a smell of bleaching powder or chlorine smell. Okay. So breakpoint chlorination comes in direct chlorination. When you add bleaching powder, also produces chlorine. Chloramine also involved, chlorine is involved. and direct chlorine is also there. That's where we are going to see the breakpoint chlorination. What is breakpoint chlorination about? Okay, in this boiling is a very general one which is used in home. Okay, so normally any water if you boil, it will be very safe for drinking. That is possible in the home level. For township, municipality, big supplies, we cannot boil, and it's not possible. So we need some chemicals which can do the sterilization job. So that's why chlorination by this 3 and disinfection by ozone is also there. Okay. Next, boiling. If water is boiled for 10 to 15 minutes, most of the pathogenic spreading bacteria are killed, and it is very safe to drinking or other consuming purposes, cooking, like that. But it is we follow in home. At homes, normally this is procedure. Sometimes we use at home as a procedure when we are not well or all those things. But it is for a long township like that, we cannot do this. So we need some chemicals directly to be added in the water to make it sterilized. So chlorination, the process of utilizing chlorine, which is a powerful disinfectant, is called chlorination. Okay. Under chlorination, by adding bleaching powder first. Bleaching powder is nothing but calcium oxychloride. If you add in calculated amount in water and allowed to stand for several hours, it produces HOCl, hypochlorous acid. Is a powerful germicide. Okay, it kills germs, microorganisms and other bacteria present in water. So this is the reaction. Calcium oxychloride plus water gives calcium hydroxide, which we also call lime, plus chlorine gas. So chlorine reacts with water to form HCl and HOCl. HOCl plus bacteria gives, actually HOCl kills the bacteria. So bacteria are killed. So that's how we can make the water safe for drinking. Okay. Okay. What is the disadvantages of this bleaching using bleaching powder? The first method of under chlorination we use by adding bleaching powder. So what is the disadvantage? Bleaching powder produces lot of calcium 2 plus hardness in water and also add a lime's residue. Okay, calcium hydroxide is a lime we have seen. So due to this, it is a disadvantage of using bleaching powder. Second, excess of bleaching powder gives bad smell and bad taste to the water. Excess chlorine is also irritating to mucous membrane. So this is how these two are the disadvantages. Okay. Even though it is very effective, these two are disadvantages in using. Next, by using chloramine. Second method under chlorination is by using chloramine. It is obtained by mixing chlorine and ammonia in 2:1 ratio. 2:1 ratio, we get chloramine and HCl. It has a better bactericidal action than chlorine. It is more stable and not producing any irritating odor like bleaching powder. It is more stable and not producing any irritating odor. Irritating odor is by, if excess of bleaching powder is there, it will give you irritating odor and smell. So odor and taste. So that is not here with this. And amine, chloramine with H2O gives ammonia plus HOCl. Again, you know that HOCl is a powerful germicide which kills bacteria in the water. Okay. So this two comes under chlorination. One is chloramine and another one is by adding bleaching powder. So the next one we will see direct chlorination also. We can see. In direct chlorination, if you add, these are all in situ. Like here, in situ HOCl, chlorine is used, HOCl is found in situ. Okay, similarly here KOCl2 in situ it is formed and then HOCl is formed. Okay, so here chlorination, directly used chlorine as a source of disinfectant. Okay, there is something called breakpoint chlorination in this using chlorination as a sterilizer. Breakpoint chlorination is defined as a point where enough chlorine has been added to a quantity of water to satisfy its disinfecting demand. So it's also breakpoint chlorination is a point where all undesirable contaminants have been removed. Undesirable contaminants have been removed from the water. Breakpoint chlorination is also called free residual chlorination. It is a controlled chlorination process. Okay, only the required amount of chlorine dose is added. That's why we say it's a controlled chlorination process. It has 4 stages. Breakpoint chlorination curve has 4 stages. So this is the 1, 2, 3 and 4th stage. Okay, so this is ongoing. This is chlorine residual. This is chlorine residual. This is chlorine added. X-axis is chlorine added. So initially when you add chlorine, there is no residual. So there is no curve here because it's all are consumed. Chlorine destroyed by the reducing compound. That means all are consumed by the bacteria. After when you add, after certain stage, when you by the addition of chlorine, residual chlorine increases. This is due to formation of chloramines and chloroorganics. That means at lower concentration of chlorine, organic compounds are not oxidized. So they require higher concentration. So here chlorine is not taken by organic compounds to undergo the destruction, but it is residual chlorine is increasing. Okay. So next, by increasing the concentration, further addition of chlorine, by increasing the concentration of chlorine, here in this stage, chloroorganics and chloramines are partly destroyed. So when they started destroying the organics, then residual chlorine decreases. Residual chlorine means chlorine present in water without reacting, without killing. Okay. So that is residual, without killing the bacteria. So residual with the further addition, higher concentration, chloroorganics, chloramines getting destroyed by chlorine. So residual chlorine decreases. So this point is called breakpoint chlorination. At this point, all the organics and other things are destroyed. So after this, whatever addition of chlorine, it remains as residual chlorine, no action. Okay. So this is the 4 stages. Okay. Okay, it is also called breakpoint chlorination, is also called free residual chlorination. It is a controlled chlorination process. Only the required amount of chlorine dose is added. Breakpoint chlorination curve has 4 stages. Okay, so this is the importance of breakpoint chlorination. Okay, as we discussed, the stage 1, no residual chlorine in the sample. As we see, there is no. All chlorine added is consumed for oxidation and destruction of chloroorganics and chloroamines. Stage 2, the amount of residual increases with increasing dose of chlorine. So this we have seen here. It increases residual. Y-axis is residual chlorine. X-axis is chlorine added. So initially there is no residual chlorine because it is taken up by the chlorine destroys the reducing the disinfection action is happening. Whatever the chlorine you add, that is taken up by the oxidation and destruction of organic presence in water. Next, amount of residual chlorine increases. The residual chlorine increases with further addition of chlorine because in this, the amount of chlorine, some organic compounds defy oxidation at lower concentration. So, chloroorganics and chloramines are formed. Okay. Next, further increase the addition of chlorine, residual chlorine decreases. This is because at this place, the amount of residual chlorine decreases with the increase in applied chlorine dose. This is third stage. Here the chlorine added is consumed for oxidation of chloroorganics and chloramines. So complete oxidation and disinfection occur at this point, breakpoint. This is called breakpoint. So fourth stage is, so this is first, second, third, fourth. The applied chlorine dose is not consumed because everything is consumed already at the breakpoint. After this, the applied chlorine dose is not consumed, so it's left as a residual chlorine. That's why again, destruction by ozone, disinfection by ozone. Ozone gives nascent oxygen. Okay, this is nascent oxygen which actually destroys the bacteria. Okay, nascent oxygen. So ozone is highly unstable. It gives oxygen plus nascent oxygen. This nascent oxygen is highly reactive, which is actually killing the doing the disinfection job, like we have seen HOCl, nascent oxygen here. So ozone is powerful and harmless disinfectant and is readily dissolved in water. Ozone is unstable, so it decomposes by giving nascent oxygen. Nascent oxygen is a powerful oxidizing agent. It's a powerful oxidizing agent. This nascent oxygen removes the color and taste of water and oxidizes the organic matter present in water. It removes the color and taste of water and oxidizes the organic matter present in water. It also kills the bacteria and microorganisms present in water. Okay. So, we have seen all this disinfection as in the fifth step. So, this is the step we have seen by chlorination. Interchlorination we have seen using bleaching powder. Second, chloramine. Third, direct chlorination, that is breakpoint chlorination. Okay, so and also we have seen ozone. by ozone. So here HOCl is the powerful germicide, hypochlorous acid. Here nascent oxygen kills the bacteria. Okay. So after this disinfection step, the potable water is safe for drinking water consumption. Okay. Is safe for drinking water consumption. So the water comes out after disinfection is called potable water, which is safe for consumption, drinking water. Okay. So these are all the steps involved in making raw water to potable water. Okay, next is desalination. What is meant by desalination? Desalination is the process of removal of dissolved salts, for example NaCl and KCl, present in water is known as desalination. What is meant by saline? Saline means salt in water, saline water. Okay, salinity in water. Salinity means salty taste in water, comes from the majorly NaCl. Okay. So the process of removal of dissolved salts, NaCl, KCl, present in water is known as desalination. Okay. That means some places drinking water, if drinking water scarcity is there, then desalination is a remedy. Okay. So water is divided into different categories based on the salinity, quantity of NaCl. So water is divided into different categories on the basis of salinity, quantity of dissolved salts. Fresh water means less than 1000 ppm of dissolved salts. Less than 1000 ppm of dissolved salts. Brackish water means salinity in the range 1000 to 35,000 ppm. It has a peculiar salty taste too. Brackish water also, due to the presence of 10,000 to 35,000 ppm, it has a peculiar salty taste. Next is seawater. Salinity is greater than 35,000 ppm of dissolved salts NaCl and KCl. So we call it as seawater. So seawater and brackish water can be made available as drinking water through this desalination process. So if drinking water in some countries or in some places is of highly scarce, then desalination is used as a remedy for converting brackish and seawater to usable, consumable drinking water, potable water. Not to the level of potable, but still to the level of drinking. So desalination process is normally carried out by two important methods. One is reverse osmosis, another one is electrodialysis. Okay. So these two methods are important in desalination process. We all know osmosis. So osmosis process, its solvent passes from low solute concentration site to higher solute concentration site through a semi-permeable membrane. So reverse osmosis is when you apply, this is natural flow in osmosis is because of osmotic pressure and concentration of solute. We call them as colligative property. Colligative property means depends on the amount of solute. Colligative property. Property which depends on the amount of solute. So osmotic pressure is osmosis is a colligative property. So reverse osmosis means if you apply higher pressure greater than greater than the osmotic pressure, then the reverse of flow happens. Solvent moves from higher solute concentration side to lower solute concentration side. So that principle is used in reverse osmosis. In electrodialysis also we have semi-permeable membrane, anionic permeable membrane, cationic permeable membrane. So when current is supplied, for example Na plus Cl minus, Na plus we go to anionic, Na plus we go to cationic membrane, Cl minus go to anionic. So there will be compartments. Okay. So one area will be more in NaCl, another area will be deprived of NaCl. So this waters collected will be fresh, this waters collected will be more in NaCl. So we'll see the more details in the next video. With this video we will stop. So we will see the more elaborate thing in of this desalination process by reverse osmosis and electrodialysis in the next video. So with this we will finish this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.